Hello students, I Hitesh Prajapati, Assistant Professor in Mechanical Engineering Department of ASOID. Once again I welcome you in my video lecture of IC engine. So in previous lecture we have studied about the introduction to heat engine, detailed difference between EC engine and IC engine. Then we have done this classification of IC engine, basic component and its function, engine terminology, the term related to thermodynamic analysis. And now students, today we learn about the working of the four-stroke petrol engine and four-stroke diesel engine with its theoretical and actual PV diagram, and we will try to plot this wall timing diagram for the same engine. Now students, we will discuss about this working of the four-stroke petrol engine, and from this working we have to plot the theoretical pressure volume diagram as well as actual diagram, and from that we have to plot this theoretical wall timing diagram and actual wall timing diagram. So the petrol engine works on principle of theoretical Otto cycle, also known as a constant volume cycle. So students, this figure of the four-stroke petrol engine is shown in this slide. You can see the valve operating in inlet is called inlet valve, and the valve operating the exhaust is called exhaust valve. The spark plug fitted on this top of the cylinder, as you can see in the figure, which are required to ignite this charge. Charge means the proper proportion of mixture of air and petrol. The piston has to perform the four stroke to complete the one working cycle, and the four different strokes are suction stroke, compression stroke, power, working, or you can say expansion stroke, and last exhaust stroke. So different stroke figure, as you can see in the figure. So students, now we have to learn about the suction strokes. What happened actually in the suction stroke? So during this stroke, the inlet valve is open, exhaust valve is closed, and the pressure in the cylinder will be the atmospheric pressure. The piston is moved from TDC to BDC, means top dead center to bottom dead center. The volume in the cylinder is increased, while simultaneously pressure will be dropped below the atmospheric pressure, and the pressure difference between the cylinder and atmospheric, this create the suction inside the cylinder. So due to this pressure difference, the charge come into this cylinder, which is made by a carburetor. The crankshaft has made half rotation, means 180 degree of crank revolution. At the end of the stroke, the cylinder will be full of charge with petrol and air. Second stroke, now compression stroke. So during this stroke, both the valve are closed condition. The piston is moved from BDC to TDC, means bottom dead center to top dead center. So at this stroke being performed, the petrol and air mixture contained in the cylinder will be compressed. So the pressure and temperature mixture is increases. The process of compression will be indicated in the PV diagram by 1 to 2 line. Near the end of this compression now, the mixer will be ignited by the electric spark, which is given by the spark plug. The combustion of the petrol is increased hot gases, which will increase the pressure at the constant volume. This constant volume, the combustion process represented by in PV diagram by 2 to 3 line in PV diagram. Now students, in third stroke, I mean power stroke, or you can say working or expansion stroke. So during this stroke, both the valve, inlet and exhaust valve are closed. The piston is moved from TDC to BDC, means top dead center to bottom dead center. The high pressure and high temperature burn gases force the piston to perform this stroke is called power stroke. This stroke is also known as expansion, or you can say working stroke, as I said earlier. The engine produces the mechanical work or power during this stroke. As the piston is moved from TDC to BDC, the pressure of hot gases gradually decreased and the volume is increased. This represented by 3 to 4 line in PV diagram. Near the end of the stroke, the exhaust valve is open. So all these burn gases or exhaust gases will be seeping out to the atmosphere, and this will suddenly bring the cylinder pressure to the atmospheric pressure, and this drop of pressure constant volume represented by 4 to 1 line in PV diagram. Last stroke students, exhaust stroke. So during this stroke, the exhaust valve is open and inlet valve is closed condition. This the piston moves from BDC to TDC, means bottom dead center to TDC center. During this motion of the piston pushes the exhaust gas, I mean combustion product, out of the cylinder at constant pressure. This process is shown in PV diagram by again 5 to 1 line. Again students, the inlet valve is open for the new cycle. New cycle is start. The engine is 4-stroke engine because the one power stroke is achieved in every 4 stroke of the piston, or you can say 2 revolution of the crankshaft. So that is why it's called as a 4-stroke engine. Students, here you can see this theoretical pressure versus volume diagram as well as theoretical valve timing diagram. So as we have discussed in earlier, there are 4 stroke: suction stroke, compression stroke, expansion stroke and exhaust stroke. As you can see in these different lines in this PV diagram. So see here the 5 to 1, which is indicate the atmospheric pressure, and at same pressure the inlet or suction is carried out. After that 1 to 2 line is indicated the compression stroke. So during this stroke we have discussed this, both the valve is closed condition and it compresses the charge which are going to be inlet in this suction stroke. So at the end of the stroke, 2 is nothing but the end of this compression stroke, and at this point the large amount of pressure and temperature develop due to the compression process, and just at the 2 point the electric spark is generate the spark to initiate the combustion. So see, this process is carried out at the constant volume. So that's why this cycle is known as a constant volume cycle as well. So 2 to 3 is nothing but this combustion process, मतलब कि heat supply process. See, uh, then 3 is nothing but the cycle highest maximum pressure and temperature point. So highest pressure at the highest pressure and temperature at the point 3. After that, whatever the heat energy is produced by the complete combustion of the gases is forcing the piston down to this towards this BDC, as you can see. So 3 to 4, the piston is going to be travel from TDC to BDC. So that's why the pressure and temperature will be going to be drop up to the point 4, and at the 4 point the heat release process is very carried out. So sudden opening of this exhaust valve, all this gas is sweeping out to the atmosphere, so that's why heat is released. But this process is again carried out at the constant volume. So as you can see, the straight vertical line 4 to 1 is nothing but the heat release process. Then after that the inlet valve is open. Now, for better understanding of this working of the four-stroke petrol engine, we have assumed certain assumptions uh, during this working of this uh, four-stroke petrol engine. So, first assumption is what? The suction and exhaust process take place at the atmospheric pressure. See, so we have seen also the in PV diagram, the suction is carried out 1 to 2 line and 5 to 1 line on the same line. So it means both the pressure are carried out at the atmospheric pressure. Second assumption, we have assumed the suction and exhaust process take place through the 180 degree of the crank rotation, means the half revolution of the crank rotation. Further two process, I mean expansion and compression process, also take place at the through the 180 degree of the crank revolution. So means the all the four stroke, suction, compression, power and exhaust will be carried out through the 180 degree of the crank rotation, मतलब कि half revolution of the crank rotation. Fourth assumption is that the both expansion and compression process will carried out by the isentropically, means reversible adiabatic process. Students, as you know that the in isentropic process the entropy will remain constant. Last assumption, we have the at the end of the compression stroke, the combustion process will take place instantaneously at constant volume. Means without any time consumption, the process of combustion will complete it. But when you look at this actual practice in actual PV diagram, the condition is totally different from this theoretical or ideal condition. So in next lecture, next PPT, we will learn about this, what are the actual scenario while the actual working condition. Now students, we will talk about this actual condition while operating on this post of petrol engine. So suction process is possible only if the inside the cylinder is below the atmospheric pressure. As we know that the students, the fluid flow occur only and only when the pressure difference is created. So if the outside the engine cylinder means the atmospheric pressure and inside the cylinder pressure will be same. So there is no any kind of fluid flow will be occur. So there must be the inside the cylinder the pressure which is lower than the atmospheric pressure. So that's why the mixer or charge can travel or flow from carburetor to inside the cylinder. So there has to be inside the cylinder the lower atmospheric pressure, below the atmospheric pressure. Second condition is that the pressure of the exhaust gas is above the atmospheric pressure, then and then only the burn gases will be sweeping out to the atmosphere. As I said earlier, at the end of this compression uh, exhaust stroke, the pressure inside the cylinder is must be higher than the atmospheric pressure, so that all the burn gases sweeping out to this atmosphere. Third condition, the expansion and compression do not any isentropic law. There will be by heat action during this process. Means we have assumed that in ideally the expansion and compression process will be isentropically. But as you know that the during this both the process there must be a heat transfer process will carried out. So that's why they do not follow the any kind of isentropic law. Fourth, the constant volume heat addition only possible because of the combustion takes some time. It means of some crank rotation for its completion. So therefore, actual rise is less than the theoretical. So as we know that this runs, the combustion is a natural phenomena. It requires some time to complete it. But in theoretical PV diagram, we have seen that the 2 to 3 line is nothing but the combustion process or heat release process. And this process is, it have the instantaneous process. So in nature, the instantaneous combustion process will never carried on. It require time in terms of some crank angle. Next condition is what? The constant heat rejection is also not possible because the sudden pressure release after the opening of this exhaust valve is no possible and it takes place with the some crank rotation. So uh, the heat rejection is also require some time. Sudden processing never happen. So that's why it requires some time in terms of crank rotation. So that's why the sharp cornering is becomes some curvature line as you see in the figure in the subsequent slide. Now students, you can observe both the PV diagram. Left one is nothing but the actual PV diagram while the considering all the actual condition, and while right side we have the theoretical PV diagram as you all already studied in this previous slide. So what is the difference between the actual and PV diagram? You can mark it. So in theoretical PV diagram, you can see the 5 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, and again 5 to 1 is nothing but this your theoretical PV diagram. While in case of the left actual PV diagram, you can see 1 to 2, 2 to 3, 3 to 4, 4 to 4 days, 4 days to 5, and 5 days 5 to again 1. See. So in theoretical diagram, you can see the only one loop is created, and while in actual PV diagram, you can see the two loop, upper loop and lower loop. In this figure, I have indicated the positive loop and negative loop. See, negative loop. If we talk about this negative loop, it sometimes is said to be a pumping loop, uh, and this is how this is created. So we will discuss. So as I talk to you, the from the carburetor, the charge will going to be inside only and only if the cylinder pressure will be below the atmospheric pressure line, right? So as you can see in this figure, the atmospheric pressure line is blue one, and 5 to 1 is nothing but the suction, which is the below the atmospheric pressure, C, as you can see, and 4 days to 5 is nothing but this exhaust process. And as I said to you earlier in previous slide, the exhaust is occur only if the pressure inside the cylinder is higher than the atmospheric pressure line. So see, the 4 days to 5 is nothing but the higher pressure than the atmospheric pressure. So due to this pressure difference during the exhaust and inlet, I mean suction, so this loop is created. See, and this loop having the work same as like the pump, Anna. So as you know that the pump has the to suction and to deliver this flow, so same kind of function is here. So said so that's why this loop is sometimes said to be a pumping loop. And I have indicated the minus negative loop. Why? Because to create the suction and to carry out this exhaust process, we require to work which is consumed by this engine itself from the power produced. So it ultimately decreases this work. Now students, upper loop I have indicated by the positive, because see, you can see the 4 days to 2, 2 to 3, 3 to 4, and again 4 to 4 days. It if you indicate the direction, so it will be a clockwise direction. So when the loop is rotated in a PV diagram in a clockwise direction, so it considered to be a positive loop. मतलब कि it uh, during this loop the engine has to deliver the work. So due to this negative loop and positive loop, the ultimately the work done by this engine will be decreased, and the work done is indicated by the whatever the work done created by the positive loop minus negative loop. मतलब कि whatever the work is consumed by this during the pumping of charge and exhaust. So as you can see this a charge. Now we will plot this actual while timing diagram for the four-stroke petrol engine from this working of this petrol engine. So while timing diagram shows the point in the cycle at which the valve are set to open and close. The valve timing has to adjusted according to the speed of an engine. A typical valve timing diagram for the slow speed engine and high speed engine. So you can observe in this my PPT. So if we talk about this inlet valve, so just concentrate on the inlet valve. So due to the effect of inertia and time required to attend the full opening, the inlet valve opens somewhat earlier than the top dead center, means TDC, so that by the time the piston reaches the TDC, the inlet valve is fully open, and this is necessary to ensure that the valve will be the fully open and fresh charge start to flow into the cylinder as soon as the piston start to move down. If the valve is open close to BDC, I mean bottom dead center, the cylinder will receive the less charge than its capacity, I mean it decreasing volumetric efficiency, and the pressure inside the cylinder would be the somewhat less than the atmospheric pressure. So to avoid this situation, the inlet valve is just kept open for 40 to 50-degree crank revolution, uh, 40 to 50-degree crank revolution of this after the suction stroke for the high speed, and 20 to 25 or let's say 30 to 45 degree for the low speed engine. The kinetic energy of the charge produces a ram effect, which forces the more charges into the cylinder during this additional valve opening. So therefore, the inlet close delayed. The higher speed of the engine inlet valve closing the delay longer to take the advantage of these ram effect, students. The inlet valve for the slow speed engine is 10 degree, or let's somewhat about around 5 to 10 degrees before the TDC, and closes after the 20 to 50 degree or around 45 degree after this BDC center. Now students, same way we have to studies about this opening and closing of the exhaust valve during this valve timing diagram. You can see in the figure, to supply the more amount of fresh charge, complete cleaning of the exhaust from cylinder is required. So earlier opening of the exhaust valve before reaching the TDC facilitate to removal all the burn gases by virtue of the pressure at this point. The kinetic energy of the fresh charge may also assist the removal of the burn gases. Sometimes is said to be closes scavenging effect, as we have studied in this two-stroke diagram. So, however, the overall effect of the opening valve prior to time piston reaches the BDC result in overall gain in output. So it increases the efficiency ultimately. The closing time of exhaust valve affect the volumetric efficiency as said earlier. By closing the exhaust valve few degree after TDC, the inertia of the exhaust gas tends to scavenging the cylinder by carrying out a greater mass of gas left in the clearance volume. This result increased by the volumetric efficiency, and if the volumetric efficiency is increased, the more amount of charge getting inside the cylinder and more burning happens and more efficiency will be delivered by this engine. So it is obvious that the valve timing diagram, the inlet and exhaust valve open at this same time as you can see in figure, right? Uh, so in the low speed, the inlet valve is open before the 5 degree Celsius degree, and exhaust valve 8 degree after this TDC. मतलब कि during this 13 degree both the valve is remain open condition, right? And this situation is called as a valve overlapping. Students, this valve overlapping it should be optimum, not too less, not too higher. So this overlap must not be excessive enough to allow to burn gases to be sucked into this intake manifold with the fresh charge escape to the exhaust valve. So exhaust valve open 25 degree before the BDC and closes after the 5 degree TDC for the low speed engine, while it closes 45 degree before the uh, 45 degree before the BDC and 20 degree after the TDC for the high speed engine, as you can see in the figure. Now ignition, spark timing you can say. So theoretically, we have it is assumed that the ignition in the SI engine occurs at the exit TTDC, but in actual condition, this ignition process is a natural process. It requires some time. So as you can see in the figure, the I mean, the ignition is occurred 40 degree before this uh, TDC in low speed engine, while as you can see in the 30 degree prior to TDC. So sometime it's said to be a ignition advance or angle of advance. Again, it is not. It is in optimum condition it require. Otherwise, the incomplete combustion may occur, and due to this incomplete combustion, the power loss may happening to this engine, and ultimately decrease the efficiency of the engine. So all this angle of advance, spark ignition advance, valve timing for this inlet and close should be optimal, so that's why we can achieve this optimum output from this engine.